The James Webb Space Telescope, also known as Webb or JWST, is a sensible trailblazer that has revealed shocking bits of knowledge concerning stars, planets, universes, and other intriguing boundless eccentricities, as well as setting new standards for logical energy. Webb is hailed as the appreciated Hubble Space Telescope replacement. Individuals from one side of the planet to the next are exchanging photos or using unrefined data to make new encounters. Go alongside us on this astronomical journey. 3 minutes back, James Webb gets the most disturbing picture at any point found in history. 1 year has passed since the significant James Webb Space Telescope uncovered its very first paramount image of the universe, dazzling stargazers all over the world with its excellent detail. Yet, its most recent finding is a shocking picture of the universe that we have never seen before. What has been viewed as doing this point by the James Webb Space Telescope is suggesting more icebreakers than it manages scientists, as the substitution to the Hubble telescope uncovered new information about star advancement, universe combinations, and the early universe. Only 1 month after the photos were conveyed to Hidden Photos, the photographs were shocking, uncovering the universe exhaustively. From that point forward, the amount of disclosures has taken off, giving scientists a gigantic data treasure mine. James Webb Space Telescope's impression of grandiose tarantulas, record-breaking space smoke stars, nearly their inestimable blast impacts, and other stunning brilliant articles have been chronicled. This satellite observatory's best-in-class advancement licenses us to peer farther into space than previously, uncovering beforehand dark nuances about the universe. Another time in cosmology is unfurled on account of the photos, which can be so organized as a technique for recollecting. The first year of the James Webb Space Telescope's movement, NASA conveyed an image that shows a small star-forming area in the Rucci Cloud Complex. The image shows planes catapulting from baby stars as colossal buildup surges of various tones influence. Nuclear hydrogen makes up the red buildup, and the presence of a circumstellar circle creates some second thoughts about a few stars, suggesting the chance of planet course of action in the faraway past. The image could show affected disorder. However, according to NASA, this brilliant nursery is small and tranquil, stood out from other, more energetic stars in this district. They are about the size of our Sun or even altogether smaller, making it the closest star-forming region to Earth. This picture was gotten by the essential camera of the observatory, the Webb Space Telescope's near-infrared camera, which gets pretentious pictures in 2 undeniable infrared ranges at the same time. Additionally, the Space Telescope has worked on our understanding of exoplanets or universes that circle stars other than our Sun. James Webb is especially perfect at looking at gigantic, faraway universes. The satellite observatory found its first exoplanet, LHS 475 billion, toward the beginning of 2023. The planet is 41 light-years distant and has a breadth comparable to Earth's. James Webb, as shown by NASA, is the sole functional telescope fit for sequencing the demeanor of exoplanets that are Earth-sized. By the analysts liable for the survey bunch that made the divulgence, the disclosures delineated how precise the telescope was. Rough exoplanets are presently one more edge for stargazers to examine. After that, the James Webb Telescope tracked down evidence of ancient history universes that, from a speculative perspective, shouldn't have existed. The EVOL lab of Swindon School and his overall cosmic gathering have tracked down 6 epic old universes called universe breakers, and they can perhaps thoroughly influence the way in which we mull over space. These enormous universes could have showed up between 500 to 700 million years later, the huge explosion, as shown by the experts' outcomes. As of late, the telescope's infrared sensors recognized them. Through the use of these instruments, we are competent to think back in time around 13.5 billion years, when stars and grandiose frameworks were significantly more laid out. The colossal boundlessness of the universe breakers has left specialists befuddled. Enormous frameworks in the early universe should have been 10 to multiple times, not exactly. Their calculations show that these 6 objects may be billions of times heavier than our Sun. How much the relative large number of stars in a single universe may be 100 billion times heavier than our Sun? Does the possibility of endeavoring to fathom something so massive give you the wet blankets, paying little heed to mechanical headway? Planets that are very tremendous to exist have experts very perplexed. None more so than the finding of a planet that is thought about exorbitantly colossal for its Sun. This has incited a reassessment of our total appreciation of planet creation and close-by planet bunch designing also as the models made by stargazers. A planet that is on various occasions as gigantic as Earth has been seen as according to research out of Penn State. Allegedly, that this planet is in a planetary structure around the ultra-cool star LHS 3154, a star that is on numerous occasions less massive than our Sun. Before lately seeing it for themselves, analysts didn't acknowledge such a circumstance was conceivable, yet new verification shows that the biggest planet in our planetary gathering is really circumnavigating one of the universe's littlest and coolest stars, an ultracool Bantam. We actually have near nothing knowledge into the universe. This finding shows it's substantially more. A planet of this mass circumnavigating a star with such a low mass beats our assumptions. These stars could have begun in enormous gas and build-up fogs. Planets may show up from the gas and build-up that stay in the plate of material around the newborn child star. After this, it isn't speculated that the planet-shaping plates encompassing the low-mass star LHS 3154 contain satisfactory strong mass to produce this planet. However, it exists. Consequently, we ought to now reevaluate our theories with respect to sublime and planetary improvement. A good relationship is to contrast the star with an outside fire. To stay aware of your inward intensity level, you ought to draw nearer to the fire as its temperature lessens. Planets are no different. Planets that should be hot enough to help fluid water ought to be closer to their stars. You can use the inward planets of our planetary gathering as a model to imagine how planets draw really smoking the nearer they get to the star. For example, our Earth is in the focal point of the reasonable zone due to the water and warmth it gets from the Sun. The distances of various planets from our Sun are either excessively great or too little for them to get the right proportion of light to help life. Now picture a universe with an unquestionably cold star. Like moving closer to the open-air fire, you'd need to do similarly with planets orbiting an infection star to get the optimal extent of force to help life. The sweep of the planet ought to similarly be altered to give the ideal distance for power and light to help life. As of now, returning to our past discussion, there are different hypotheses regarding the reason why the planet could have outlined near the little star. As shown by a generally held conviction, the planet could have been generally greater. Before, as time went on, the world would have lost a critical piece of its mass. However, this hypothesis has a key blemish because bad mass causes a planet to lose more gas than solids. In this present circumstance, it is speculated that a large portion of the planet's mass would have been vaporous, which is clashing with the tracking down. Another explanation is that this enormous planet was formed way off the mark to the infinitesimal star. Assuming the planet had the option to stay away from the low-mass star without getting a great deal of light, it would probably be ice-covered. The star could at last gravitationally attract this distant planet, which would achieve this colossal planet being close to this little star, disregarding the reality that the two makes that there an expected consideration could bring about the notification planet and star pair. Analysts are still unfit to make a decisively feeling of the quirk as of now. With state-of-the-art headways like the JWST, researchers are now checking out planetary gatherings in more detail, and each crisp finding is pushing them. We have plunged all the more profoundly into how the universe has framed over the span of recent months than we have before 30 years. The colossal gathering of information that the telescope offers has already provoked major sensible advances that have stunned stargazers and worked up interest in future space travel. With the James Webb Space Telescope working for a year now, one thing is definitely the universe is fundamentally more tangled than we previously imagined, and there are a piece of requests that we are yet to answer. The James Webb Space Telescope, a marvel of human ingenuity and technological prowess, orbits silently in the depths of space, its watchful gaze scanning the cosmic tapestry for clues to the mysteries of the universe. As it peers into the vast expanse, it captures breathtaking images of celestial phenomena, from the birth of newborn stars to the cataclysmic explosions of dying ones. With its advanced instruments and precision optics, the Webb telescope has revolutionized our understanding of the cosmos. It has unveiled the intricate dance of galaxies millions of light-years away, shedding light on the processes that shape the fabric of space and time. But perhaps its most awe-inspiring discoveries lie in the realm of exoplanets, distant worlds orbiting stars beyond our solar system. Through meticulous observation and analysis, The Webb telescope has identified planetary systems unlike anything we've seen before, from scorching gas giants to rocky worlds teeming with potential for life. Yet, with each revelation comes new questions. What unseen forces sculpt the formations of galaxies? How do planetary systems evolve over time? The Webb telescope stands as a beacon of curiosity, beckoning us to explore the unknown and unravel the secrets of the cosmos. As we embark on this journey of cosmic discovery, guided by the keen eye of the James Webb Space Telescope, we are reminded of the boundless wonders that await us in the infinite expanse of space. With every image captured and every data point collected, we edge closer to unlocking the mysteries of our universe and understanding our place within it.